Origami is the ancient art of paper cutting and folding to transform a flat sheet paper into three-dimensional structures. And what we demonstrate here is a simple origami method called pulling flower. A typical origami process involves three steps, between which we need to cut the paper with scissors and fold the flat surface into the finished sculpture. This extremely simple process doesn't require any additional materials or tooling, so we wonder if it is possible to scale down the process and use the same principle on building nanostructures. We know at the nanometer scale, we cannot use real paper and scissors, so we get started with large pieces of gold nanofilms as our paper, and we use the focused beams or ions as our scissors. We use highly concentrated beams to remove the material, followed by a global exposure, which will interact with the nanofilm and deform it into three-dimensional structures. So with this novel origami technique, we're able to make very complicated architectures, including spider webs, a rotating mechanical fan, and pinwheel structures. I still remember when we first photographed the deformation process of these origami patterns, we were really surprised by the visual resemblance between the nano origami and their counterparts at the visible scale. We compared the mechanical performances of various patterns, and it turned out that the novel design of web structures, basically it's a whole bunch of offset circles, is more resilient and can withstand much larger deformation than the typical web a spider makes. A natural question that people may ask is, what can we do with the nano origami technique? Well, there are actually so many possibilities that are opened up by this extraordinary novel technology. For example, we can have more control over the properties of light at the nanometer scale. With this technology, conventional paper cuts by origami can be scaled down 10,000 times, which is almost 100 times smaller than the thickness of human hair. It is very promising that many current mechanical and electronic devices can be made more compact without compromising their functions.